Nick Henshue traces his passion for the environment to his teen years, when he worked summers teaching camping and wilderness survival at a Boy Scout camp.
The experience was a constant bombardment of feeling amazed and captivated by every single living thing that I saw.
Henshue became a high school science teacher out of college, then went back to university for his PhD, and today is an associate teaching professor of ecology at UB. His research aims to understand the ecological impacts of invasive species and to develop effective restoration strategies, particularly in regard to the earthworm. Welcome to Driven to Discover, a University at Buffalo podcast that explores what inspires today's innovators. My name is Cheryl Quimba, and in this episode I'll be talking to Nick Henshue about earthworms, both the surprising harms they cause and the promise they hold. Thanks so much for joining us today, Dr. Henshue.
I have no idea how I got here. I just went out for a cup of coffee and somebody threw me in a van.
Well, I'm glad you made it in. So let's start with what first sparked your interest in ecology. Were you a nature kid?
I was so much a nature kid. I got beat up a lot in elementary school, so I tended to hang out in the woods by myself, and we had a bunch of acres behind our house, and I would just wander off. I had a student ask me a couple of months ago now, was I a stick kid or a rock kid? And I stopped because no one had ever asked me that before. It's like, apparently there are two different groups of people. So I was a stick kid, as it turns out. I actually have in my office some sticks I gathered when I was maybe 12 or 13 years old, and we actually used that as a microphone stand for our seminar series. What were you? Were you a stick kid or a rock kid?
Oh my gosh, what a great question. I would have to say rock, a rock kid. I like to build. Yeah. And you also were at a Boy Scout camp, right? Teaching camping, wilderness skills. What was that like?
It was terrific. It really led me to understand that I was a teacher. I had the heart of a teacher. And if I could teach kids about the environment and about what they're surrounded by, then it was incredibly satisfying and fulfilling.
And then you went on to teach science in high school. What inspired you to pursue your PhD and a university position from there?
So I had the time of my life teaching high school. I actually started with 7th grade life science, and then I taught 8th grade physical science for a year. And then I moved up to 9th grade earth and space science. And every time I moved up, it was even more fulfilling. Eventually, I got to teach 11th and 12th grade environmental science, and that was the best. And then I got to the time when I realized that public education wasn't so much about the kids anymore, and it was more about state-mandated testing and No Child Left Behind and Race to the Top and all of these initiatives that were done with good intent but had forgotten about kids and the importance of just letting that wonder of discovery captivate them. And so I become kind of disillusioned and burned out with teaching high school. So I quit. I walked away from a great tenured high school teaching job and went back to Rutgers for my PhD.
So let's talk earthworms. You're an expert in earthworm ecology with a special focus on how earthworms affect habitats in Western New York. How did you get interested in earthworm ecology?
When I was teaching high school, I had a workbook of activities and labs to do with students at the high school level about invasive species ecology. And one of the activities that was in there was about earthworms. Earthworms were invasive, and there were actually no earthworms in the northeastern United States until humans brought them here. They were pushed really, really far south down kind of, we believe, into the Great Smoky Mountain ranges. But with us, moving around landscaping materials, building materials, any kind of mulch, things like that, and especially bait. All of those things helped really spread earthworms fast. And it blew my mind. It blew my mind because we were raised to think, earthworms are super great for plants, and they're great for your garden, and they're great for this, and they're great for that. And that's all absolutely true, except that forest ecosystems that had adapted the last 10, 12,000 years without earthworms in them. The kinds of forests that we have here in the northeastern United States, we're used to not having them. And so when we add those earthworms into the system, now we've got a very delicately balanced forest ecosystem that is suddenly losing topsoil. It's losing nutritional profiles in the soil. It's losing the litter layer that's covering up all of that topsoil. And so earthworms ended up not being so terrific for forests. And this was kind of like a, wait, what do you mean kind of an event in my life? Because how could earthworms be bad? And it led me down this rabbit hole, and here I am 20 years later.
Wow, that is fascinating. So, this notion of invasive species versus native species. Can we dig into that a little bit more? It sounds like it's very context specific.
It is super context specific. And that's the thing, is there's a ton of nuance with anything in ecology. There's about 183 species of earthworm in North America. 62 of them are considered to be invasive. The levels of invasiveness are, of course, very context specific as well. So what we find being troublesome in a forest in Minnesota might not actually be a problem at all in a forest in Virginia.
Okay. And I know you've talked before about how trees communicate with each other, right? Under the soil. We're just sort of starting to come to an understanding of what that process is like. So how are earthworms disrupting that process? What role do they play there?
So if we have a soil-dwelling earthworm, as opposed to earthworms that are composting earthworms that are kind of found on the litter layer, those root zone earthworms preferentially really, really like to eat mycorrhizal hyphae. And those little fungal hyphae are connecting one tree to another, and we're just beginning to understand the nutrient dynamics that happen between trees that shunt off nutrients and send them to other trees that might be struggling a little bit, or even the fungus creating a system where they'll actually trap tiny microinvertebrates and digest them and send those nutrients from the bugs into the tree's roots. We're just starting to find out about all of these things, and now we have earthworms that are preferentially eating those mycorrhizal hyphae. And so it's actually changing forest soils from a fungally dominated system where there's an unimaginable amount of connections, little telephone lines between roots, between trees, between plants. And that entire system is being replaced with a bacterially dominated soil, because after the earthworms go through there, they're also enhancing the amount of bacterial productivity through their feces and their mucus.
You mentioned a term that I haven't heard before, mycorrhizal hyphae. What is that?
Mycorrhizal hyphae are the actual working part of a fungus. When you see a fungus, you think of a mushroom. A mushroom is the fruiting body. That's the spore producing part, the reproductive part. That's what goes on your pizza. But underneath that are these tiny little filamentous hairs that connect from one of those fruiting bodies to another. And so imagine the hair that gets caught in your drain is mixed in with the soil. And those are what are connecting one tree to a fungus, to another plant, and all through the soil. Those little fibers, those mycorrhizal hyphae are connecting things so delicately that in some pine forests, we actually find mats of them just under the soil surface. And those hyphae create a mat of maybe 3 feet thick of just fungal threads that are doing what fungus does, collecting nutrients, collecting water, helping to decompose soils, all of those really terrific ecosystem services.
And the worms eat these little hairs. That's what's happening
They're
here.
delicious.
So let's zoom into Western New York. 5 years ago or so, you sounded the alarm on the arrival of jumping earthworms to the region. Can you explain what they are and what's so dangerous about jumping earthworms to this local ecosystem?
So there's a lot of invasive earthworm species that have sort of negligible effects. And as they get into forests, they do alter things, but not in the way that the Amenthus species do. So the Amenthus species complex is all of the jumping worms. The Amenthus species are incredibly damaging to forest ecosystems because they are leaf litter experts. They don't really go into the soil. They stay in that composting leaf layer on the forest floor. And within just a month or two of good summertime weather, they can take down 4 or 5 inches of thick leaf litter, exposing that soil to sun, exposing it to drying out, exposing it to wind and rain. And because they process that soil through their bodies, the resulting granularization, we call it kind of looks like taco meat or ground beef on the forest floor. And that's exposed. And those little balls of soil will roll away, wash away very, very quickly. And we lose sometimes several inches of topsoil in one winter just from the Amenthus earthworms, those jumping earthworms.
So it sounds like jumping earthworms can be very destructive in forest habitats, forest ecosystems. But what should regular folks know about jumping earthworms or earthworms in general?
So earthworms in general are terrific. This is part of the nuance. You want them in your garden. You want them in your flower beds. You don't want them in your forest. And sometimes you can't stop that. There's no way that you're going to go out there with tweezers and pick up all the little earthworms, but we can be very vigilant about where we get our mulch from. We can be very vigilant about community composting piles. Anything that is bagged or industrially composted, because of the bacterial action in that compost can get about 140 to 145 degrees. That's why sometimes in the wintertime, when you drive past a big heap of mulch, it'll be steaming. That's bacteria in there that are warming up that pile. If it's gone through that process, there's not going to be earthworm eggs in there. But if it's just a local community, kind of everybody brings their Christmas trees and their food scraps and mixes it up, it's not necessarily going to be heat treated. And that is where we're actually seeing a lot of the spread in Western New York. The Amenthus jumping worms are from community compost piles.
So why are they called jumping earthworms?
The other species of earthworms that we have in Western New York behave exactly like you know an earthworm behaves. It slow wiggles. It sort of, meanders. It can bloop down into holes if you come too close to it. Those are all expected behaviors. What's different about the Amenthus jumping worms that we have here is that they wiggle and thrash and really behave in a very snake-like way, like an agitated snake.
So they sound very distinct from the typical earthworm that we would encounter just slithering across the sidewalk after it rains or in our gardens.
Yes. So those earthworms that you see crossing the sidewalk are actually not drowning like you were told they were. They can live quite happily underwater for weeks at a time. What they're doing is they're coming up, they're finding a mate, and they might be switching their apartments, right? So they're coming up for dating and real estate. The jumping worms, on the other hand, are going to be found late on in the summer because unlike almost every other earthworm on the planet, these guys are only annuals. So they lay their eggs in October. Those eggs overwinter, and as soon as the soil temp reaches about 50 degrees consistently, those eggs will hatch. Those tiny little squiglets are not going to be noticed at all throughout the entire summer until they get about as big as a pencil. And they're going to be rainbow colored iridescent, slightly purplish sort of hue. That ring that goes around them, that clitellum, is going to be really smooth, not puffed out. And it's going to be like a light cream color. And that, along with the behavior, is going to really allow you to identify those Amenthus jumping worms very easily.
Okay, so very distinct from most other earthworms. Much of your current research is on remediating contaminated soil, using earthworms along with native plants and other organisms. Can you speak to that?
One of the things I really love about Buffalo, we moved here 8 years ago and found a city that is full of life and is coming back to what the former glory, or even better than the former glory, was. But we have 200 years of industrial sins that we need to pay for. And we have a ton of brownfields and post-industrial sites that need some love. And so when we look at this ecology that is very nuanced in these restoration sites, we see the real need for thinking through having earthworm communities and native plant communities and native pollinators and all of the things that will help all of these kind of forgotten, marginalized areas to come back and be healthy, vibrant ecosystems that are capable of supporting different ecologies.
And what role do you see earthworms playing in that sort of regeneration process?
Depending on the type of soil contamination, those earthworms can help to overturn soils, they can help to aerate, and they can help to relieve compressed soils, things that have been under concrete or have been driven over many, many times, right? To aerate and kind of fluff that soil back up, to allow the insects and the different microorganisms to really get through and help that soil back to life.
Let's switch gears to your teaching. You're known for your dedication to your students. I remember the first time we met, you told me that teaching was your superpower. What did you mean by that?
I realized pretty early on in my academic career that what I was really good at was bringing people together and sharing that enthusiasm for the natural world around us. And so I really leaned into that. I leaned into creating multiple different outreach avenues within Western New York, the broader community, and within our own department and college here at UB.
That leads me to my next question, because I know that you co-direct the Earth Ed Institute at UB, which is a pretty unique program. Can you talk about that?
The Earth Ed program is basically it's summer camp for science teachers. We bring in research scientists and they share what they're doing, the best current technologies and cutting edge research. And then we work with the teachers and give them activities and lesson plans and labs that can re-energize their classroom. So it's great for the teachers because it's fun, nerdy summer camp. And it's great for us because we actually get to share all of the little magic that we do in each of our very specific sub-disciplines.
We're at a critical juncture in terms of the environmental health of the planet. So how do you keep your students, including, say, these K through 12 teachers who are part of the Earth Ed Institute, how do you keep them engaged and optimistic about the future now?
I know it doesn't always feel this way, but environmentally, we are heads and shoulders above where we were just 50 years ago. All of the environmental regulations that really started back in the early 1970s made drastic improvements. You know, think about how a car used to smell when it drove down the road in the 80s and 90s. Now we don't have that, right? We have more cars, but they're a lot less polluting. We have cleaner rivers. We have cleaner lakes. All of these are improvements. And sometimes it doesn't always feel that way because we see the pollution, we see the wounds. Like Aldo Leopold said, the problem with an ecological education is that you live in a world full of wounds. We're seeing all the trash and all the litter, but forgetting what the trash and the litter looked like in 1985 and how far we've come. The way we stay optimistic is by focusing on the good, by focusing on the kindness, by focusing on the empathy. We're headed in the right direction. And there might be some setbacks here and there, but overall, we're moving in a forward, positive direction.
Thanks so much for sitting with us today, Dr. Henshue. This was a fascinating conversation.
Thank you very much for having me.